Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I am Mr. Kadim Khan and I am a lecturer in the Institute of Computing, Kuwait University of Science and Technology. Today we will take lecture number 11 of the subject of object-oriented analysis and design, in which we are going to discuss the system behavior model with the sequence diagrams. Dear students, the system behavior model is represented with the help of a sequence diagram. The system behavior model represents the functionality or the behavior of the system, and that behavior is provided to the end user. So here we will discuss how that behavior will be represented with the help of the sequence diagram of unified modeling language. This is the discussion agenda. It contains the topics of what is a sequence diagram, drawing a sequence diagram notation, actor, lifelines, messages, message categories, and guards. And at the end, we have sequence diagram examples. Dear students, sequence diagram is very much important for yourself because you have to provide the sequence diagram of your final year project in your thesis. So that's why understanding of the sequence diagram is very much important. And also it's very much important because the sequence diagram represents the behavior of a system. Now, before starting this sequence diagrams, we have to understand that what is the sequence diagram. As its name indicates, the sequence diagram is used to represent the interaction among different objects in a certain sequential order. Here, the sequence of interaction is very much important. The interaction represents the interaction of the actor with the system. So, in the sequence diagram, we use certain events which are in fact representing the functionalities of the systems, and that events are in fact organized into certain sequential orders. Here the sequence diagram describes or represents that how and what orders the object is in the system functions, means that there are different objects in the system and how they are interacting with the users in a certain sequence. The objects represent different clauses and each and every clause have different functions. So the functions are associated with the objects and that objects are in fact representing the men or the large amount of components of the systems. Now sequence diagrams are mostly used by the businessmen and the software developers to develop and understand the requirements for the new and existing systems. The businessman is a certain person which represents the business value of the softwares, and they are very much interested with the return of investments. Means that they in fact provides the business value as a form of the different sort of the budgets and costing over the projects, and then at the return they want some benefits from the project in the form of their business values as well. So business persons have very importance about the project because they have to sell the project. That's why they are very much interested in the development of the project. Similarly, software developers who are the programmers, they have to develop the softwares and they have to understand what sort of the function and requirements of the system are, so that they will implement the system according to their particular functions. Now to draw sequence diagrams in a tool, we will use visual paradigms or Eclipse IDE. So that is used to visualize a sequence diagrams in which different sequence of operations are specified. Here we have one incoming message and also one outgoing message. So this one is specific one incoming message, and then that incoming message goes to another module are functions as a form of an input to another functions, and that function also replies here. And then again you can see that here another function is invoked, and then after completing that function return results to this module, and at the end we are provided with the final results, which is the balance. Now this is the specific examples of a sequence diagram. When you will draw a sequence diagram in certain tool, then you have to use the standard format of the sequence diagram, which is here with us. First of all, we have SD, that is sequence diagram. Then we have the name of the sequence diagram, balance lookup, and then this sequence diagram is acting as a function which takes in integers account number and it returns integer. That means that when account number is provided, then it returns an integer as a balance. So first, the get balance function is called of the buyer banks object of the bank class. Then this function in fact invokes the retrieval account functions where account number is provided as a parameter. But this function is implemented in the ledger object of the account ledger class, and then it provides the buyer accounts number as a output, and then get balance function is called of the buyer's accounts checking account class, and it returns the balance to the bank class where the buyer bank object is invoked, and then that buyer's banks object returns the balance to the user. So this is the sequence diagram which defines that there is a sequence of operation when you want to check the balance of your bank accounts. So you will in fact revoking the multiple other function in a certain sequence. We have standard notation for the sequence diagram. The first notation is called the actor. An actor in a UML diagram represents a certain role where it will interact with the system and other objects in the software. It is important that an actor is always lies outside of the scope of the system. Means that this actor will be always in fact lies outside of the project, but this actor, when it will invoke another functions, it will communicate with the different classes of the project. So as the classes will be defined in the UML diagrams, not their details will be provided. That means there will be no coding here. So we use the actors to show that the various roles which have including the human users or other external subjects are defined through the actors. Means that actors may be a human users, like for example a student is the actor of the KCMS, but it can also be the external objects. For example, the camera act as an actor that will provide input to the face detection systems. So that means that actor can be a hardware or software, or it can be a human or other object as well. You can see here there is an actor which is a user. This actor is interacting with two different modules. One is the Theater 2 and Theater 2 as the object theater, and similarly we have Server 1 which has the object server. Now first the actor will insert a card into Theater module, and then the actor will select the date. You can see this is the sequence of operations. So after providing in the card and the date to the theater objects, then the theater object provides or offer the seat number to the actor. Then the actor submits the orders to the theta 2, but this order goes to the server 1 of the server object. Submit order is provided to the server object, and then the server object confirms the orders, and the confirm order confirmed is provided to the end user, that is the user here. So this is the sequence diagrams which describes how different operations will be called through the sequence of the different functions or different modules here. Here we have two different modules, and these are multiple functions, and these functions has, for example, you can see that they have certain straight lines which shows that the system is accepting the input, while dotted line shows that the system is providing the output to the user or the actor. Another important notation in the sequence diagram is called the lifeline. A lifeline, as its name indicates, it depicts the individual participants in a sequence diagram. Each instance in a sequence diagram has a lifeline. Lifelines are located at the top of the sequence diagram. So the standard in UML lifeline is following the format like that: instance name and the class name. Here class 1 is in effect the class name, and X is the object, and that is the lifeline. And lifeline is in fact represented with this dotted lines, because that says that we can say that this class which has the object X is in fact existing through its life in the interaction with the actor. So it means that this class is interacting with the actor, and here that is the lifeline of the X object belonging to class 1. Another different notation of the sequence diagrams is the difference between a lifeline and an actor. A lifeline has an object to internal to the system, whereas actor is used to show the object external to the system. You can see that there are two lifelines, that is customers and bank. The customer has KUST_1 as the object, while bank 1 is the object of the bank class. So it means that in the lifeline there are two different classes here, but the actor will always lies outside of this sequence diagram somewhere here. So this is the example of the sequence diagrams which shows that there is the difference between lifeline and an actor. So lifeline resides inside of the sequence diagram, while actor always is shown outside of the sequence diagram. Another important notation used in the sequence diagram is the messages. So messages shows the communication between two different objects or more than two different objects. So messages are always shown as a sequential orders. Here you can see that there is the order of this message, and this is shown as in the lifelines, and the messages are represented here with these arrow lines. Now you can see there are three different classes. One is the customer class, second one is the bank class, and third one is the insurance agent class. Now every object has in communicating with another object, and the communication is performed using the calling of the different functions or actions. For example, synchronous message is sent from the customer class to the bank, and that represents the message, and every message is labeled with the number to show the orders that in which these operations are called. So first this operation will be called, second asynchronous message operation will be called, third participants creating message will be called, then fourth is participant deletion method will be called, and next is fifth self message will call me that this module is calling itself, and then we have the sixth message, that is reply message is here available, and that will be the final message. So the message represents the sequence of operations and as well as sequence of calling to different actions. Message can be classified into two different categories. First, synchronous message and asynchronous messages. Synchronous message, as its name indicates, it waits for the reply before the interaction can move forward. So here the sender will wait until the receiver has completed the processing of the message, and the callers will continue when it knows that the receiver has processed the previous message. So that means that the receiver will always reply a message here. So here, as its name indicates, synchronous messages are those messages where the sender and receiver are synchronized. When the sender sends message, the receiver will not will receive the message, and when the receiver will process the message, the sender will not send the messages more. So until if receiver is ready, then the sender will send the messages. So that is called synchronous communication between different objects in the sequence diagram. So it is in fact in object-oriented programming, all the messages are performed through synchronous communication. So here we will use the solid arrow lines to represent synchronous messages here. This is the example of the synchronous messages. There are, you can see, two different classes, user class, device class, and the user class is communicating with the device class through the message that open application, and then the device class will reply that applications are opened. So it means that this is the reply to the user. So whenever when the device is processing, then the user will not send another message to the device until it receives a message from the device. Another types of messages called the asynchronous message. In the asynchronous, as its name indicates, that the sender and receiver will not bounce to be synchronized. So here the sender can send the message as many as messages to the receivers if even the receiver is not ready. So here interaction moves forward irrespective of the receiver processing. So the previous messages are not received or received. So here the line arrows heads represents in asynchronous messages. So you can see there is the line heads, so that represent the synchronous messages. Now, how we can create the messages to show that the new objects in a sequence diagrams are interacting with each other. Here, a particular message call is required to create an object, and it represents a dotted lines to the arrows, and they create a word labels over it here that the message is created. Here you can see that new order is created here. For example, creation of new orders, that is e-commerce websites, will be created here. If a user want to orders or create the order, so new message will be created here to create the new orders. That is the create new message. And similarly, as against the new create message, we have the delete message as well, which is opposite of the create message. Here the message will be deleted. The message will be deleted when the message is completed or the processing has been completed. For example, when the order is received, then the order's received message will be deleted, because in this way it will be required to deallocate the memory so that the system become very much efficient. So when we use a delete message to delete an object, then the object is deallocated memory or it is destroyed within the system that we have used to delete the messages. Here, the NX, which representing that the deletion of the message, is provided as a symbol for deleting that particular message here. Means that up until this position, this sequence of operation has been completed and it will be not processed anymore, so that the memory will be become deallocated and the system will become efficient and the processing speed will be improved. Another notation in the sequence diagram is called the self messages, and the self message means that when the object call itself, then the self message is called. So here, assert a scenario where the object requires to send a message to itself. In this sequence, the self message will be called here, and self messages are represented with a U-shaped arrow. This is the U-shaped arrows. Also, there is another example of the self message, that when a user want to communicate with the device, then the user will send open application message to the device module, and then the device module will call itself, that is opening webcam. So means that the device module will send the message to itself, and this scenarios the self message is represented, which is called to itself. Also, we have the reply message here. The reply message is represented with this line. Means that the replies message is used to show the messages which is sent from the receiver back to the sender. Here, a reply message is used to open arrow ended with the dotted lines. You can see that these are the dotted lines. That means that the message is sent to the receiver's here. So the interactions moves from forward when a reply message is sent by the receivers. Here is the examples where a device requests a photo from a user and the message which shows the photos is being sent as a replies message here. So first of all, user will open the application. That means the user will send the message of open application to the device. The device will call itself the access webcam, and then the device will send the message to get photo to the user, and the user will again send the reply message to the photo here, that the photo has been received to the users. That is the reply message. Another important notation of a sequence diagram is the found message. The found message has this symbol. It represents that the message has been found. So a found message is used to represent a certain scenario where an unknown source sends the message. That means that here you can see that there is no source is available as an input to this message. That is the unknown source, and it is represented with the filled circles, and the filled circle is with the black colors because this is the unknown source. So here an arrowhead is directed towards lifelines from the endpoints. That means that here the message is sent to the device modules here. For example, here we have the hardware filler examples, that when a users open the applications by opening the send message, then the web access is called as a self message, and then the hardware filler message is received from an unknown source. That what are the causes of the hardware fillers, that we are not aware of these fillers. So it can be due to the multiple reasons, and there is no certain, not as certain as that what cause of the hardware as filler is. Means that there is no reason that why the hardware has been filled. So that's this one is a found message, and it is an unknown message sent from the unknown source. Another one is the lost message. Lost message is in fact uh, uh, exactly like the found message, but this is in fact little bit different because you can see the arrowhead is pointing towards the unknown source. Similarly here, this is the symbol that the arrowhead is pointing towards some unknown source here. So a last message is used to represent a scenarios where the recipient is not known to the system, that who is the recipient of this warning message, that we are unknown that to whom this warning message has been sent. So it here is representing an arrowhead directed towards an endpoint from a lifeline. For example, you can consider here that the scenario where warning is generated that if the hardware has been filled or there is certain reasons that the warning is generated to unknown source here. So here an output message will be provided to the unknown source. And at the end we have the guards here. The cards usually represent a certain conditions in UMLs, exactly like that. For example, if-else statements in a programming represents the conditions, we have the guard statements here represented with this all symbols here. So when we want to restrict the flow of message on the pretext of a condition that the certain condition are met, then we use the guards here. For examples, here the customers is using the bank. But if the bank balance of the customer is greater than 0, means that that is not equal to 0 or negative. So that means that then the customers can interact with the bank in that particular situation. So in order to be able to withdraw cash, then the customer's balance must be greater than 0, and this is the condition that must be met, and the condition is shown with this symbols, which is in fact all symbols representing that when the customer is interacting with the bank, then the balance should be greater than 0. This is the sequence diagram of emotion-based music players. This is the example for you. Dear students, you should study these examples because exactly like this, you have to create the sequence diagram for your FIP documentation or for your thesis. So here there are 3 different modules: users, device, and database. So user module is communicating with the device and device module is communicating with the database. So first user will apply for open applications to the device module, then device module will call self message to the web access, then get photo is provided to the users here, and then user will detect the face. That means that the face will be act as an input to the device modules, and then the device module will take that face, retrieve the mode, and the mode will be in fact searched in the database, and then the mode will be provided to the device module, and device module will display the mode to the end users module. That will be maybe as a user interface module. And also the mode will be provided here again to the database, and database will retrieve music again according to the mode of the user. So retrieve music will be provided to the device modules here, and also generated playlist will be provided here. That there are multiple playlists of the music modules, then all these playlists will be provided to the device module, and the device module will send the playlist to the user here. So here the user is accessing the database of the music libraries according to his or her mood. If they are in a happy mood, so that means that music will be played according to that module. If they are the sorrow or in sad module, then the sad music will be played for the users. Now, uses of the sequence diagram means that how and why we should use the sequence diagram. Basically, the sequence diagram is used to model. Model means to provide the basic designs and is used as a visualized format of the problem, representing the logic Behind that sophisticated function, operation, are procedures. Means that all functions, procedure, and operations are provided in the form of the visualized formats, and that format represents a model of the usage. They are also used to show the detail of UML use case diagrams, means that all the use case diagrams can be represented with the sequence diagram, but sequence diagram is one step up than the use case diagram because it also represents the sequence as well. So it shows the detailed functionalities of the current or feature system, means that what should be the current features and the functionalities of the system. Also, it shows the visualization of the all messages and tasks which moves between multiple objects or components in the system. So if we have multiple components or objects of the systems, then all the messages in the form of the functions are represented in the visualized format in the sequence diagram. Dear students, this is the end of the lectures. This is a reference book for yourself. If you want to study more about the topics, you should download this book. This book is the Springer book of the modeling with the UML language concepts and methods, and written by Rumpf and Bernhardt. So you have to download and study this book, which is very much important books for yourself. And still, if you have any question, you can ask the question through this email. My email is m.kadeem@kust.edu.pk. I will wait for your questions and will respond you soon as I get your emails. Thank you very much.